Hey there everyone, it's your math teacher Mr. Boyden back at it again today, and we're continuing with our discussion of similarity, in particular with triangles and different ways of applying proportions to triangles. Let's get to it. Today, let's start with a question rather than an answer, and here it is. We've got a diagram on the screen, and I want to know, how do we know that those two triangles are similar? Okay, we've got a triangle on the top, triangle on the bottom. Some people say they see three triangles. They'll cite this shape that I'm tracing right now as that third triangle. That's actually a trapezoid. That's not a triangle. So only two triangles. We've got the one up top, and then the whole picture is a triangle. So back to the question, how do we know that those two triangles are similar? Okay, well, first thing, look at what we've got right here and right here. Do you remember what those markings mean? They're not saying that the sides are the same length, because look, we can clearly see that RS is quite a bit shorter than XY, so it's not same length, it's claiming that they're parallel. And if they're parallel, that means we're going to have some congruent angles. Like right here, angle 1, I bet you could tell me this, angle 1 is the same, or is congruent to, what other angle on this picture? Okay, that's angle 3. And why? Because they are corresponding. And we learned that in our second unit, that anytime you have parallel lines, corresponding angles are going to be congruent. Okay, what about over here? Angle 4, could you tell me what angle 4 is going to be the same as? Angle 4 corresponds to angle 2. And so now, let's answer that question. How do we know that we have similar triangles? Because we have angle-angle similarity. And that goes back to what we learned 2 lessons ago with our similarity theorems and postulates. Okay, so by angle-angle similarity, anytime we have a triangle that's being cut in half in the middle somewhere with a parallel line to that side, we're going to have similar triangles. Okay, now based on that, that means we can apply proportions to them, because that means we have proportional side lengths. And one way I'd like you to think about it is this. Think about it like this was the original shape, and like the big triangle is the result of a dilation. Okay, so it's like we stretched R got stretched down to X, and S got stretched down to Y, and Q stayed right where it is. Okay, so we started with these two side lengths, QR and QS, and then we added on this extra part right here, RX, and we added on SY. Now guys, you could probably see just that SY is longer than RX. But in order for this to be parallel, those had to be proportional, okay? So we added on proportional amounts to either side. Let's take a look at how we can use it in practice, and I'll show you a little bit of a shortcut for some of these questions. Okay, here we have a diagram. You may want to pause the video and draw it. We're going to find why. And one suggestion as we get started on this, let's try to make this look exactly like what we just learned, okay? Because this looks like it's kind of twisted, so I'm actually going to take a minute here. I'm going to grab my triangle, and I'm going to twist it. Now in class, you usually are not going to have a computer, but what you do have is a notebook. So you could draw down the picture just as it is, and then you could physically rotate your notebook on your desk, and that would work just fine. So guys, here's the trick. Okay, when you have parallel lines, we said that these extra sections that we added on, or that we dilated, would be proportional to what we were given. And so that means that we can set up something like this. And here's the trick. The thing on the top left, I wrote on the top left. The thing on the top right, I just wrote it on the top right. The thing on the bottom left, write it on the bottom left. The thing on the bottom right, you write it on the bottom right, okay? So let's make sure we understand that you can only do this, first of all, when you see parallel lines here, and it has to be these side lengths that are made up of 2 pieces now, okay? So if I had 5 and 10 right here, I'm not allowed to use those, because those are not the sides that got extended. Okay, so be really, really careful with that. It has to look just like this picture. But it is a nice little shortcut, and now that we've got it, we can proceed and figure out what y is, and it's pretty quick. So here we go. 12 times 6, that's 72, and I got 10 times y, and that would be 10y, and let's divide out the 10. And so it appears that we have 7.2 equals y. And so to add on to that just a little bit, that's what I'm talking about when I say proportional. Look, 12 was bigger than 10, so whatever we added on here to make it proportional, we would expect would also have to be bigger than 6. See? 12 is bigger than 10. This, which we found out is 7.2, is bigger than 6. Okay, and that's what we would have expected there. Okay, so we're going to get a little bit more practice, a little more familiarity, but that's how they go. It's a neat little trick. Okay, let's try this one. Why don't you go ahead and pause the video and try to do this entire question by yourself without any help. See how much you can do, and then when you play the video, you can get some feedback on how you're doing, and you'll know where you're at. Okay, so here I go. So if you haven't paused yet and you want to, please do that now. Okay, here's my setup. And I'm going to cross multiply. Looks like 5 times 16 is 80. and I get 10x dividing by 10, and I get 8 equals x. Let's try another one. At first, some people don't think this is the same type of question. You say, but wait a minute, where are the triangles? Well, folks, can you imagine if this side continued up and this side continued up, eventually they would make a triangle, and so we just have more than one cut. Okay, we have more than one segment going across this triangle. That's not a problem at all, because that just means we have the same scenario we've been learning about today, we just have it multiple times. The other thing that freaks people out a little bit sometimes is we have both x and y on here. People, that's not a problem at all. Okay, so check out how we're going to set this up. If you haven't yet, make sure you got the picture down, make sure you're ready for your notes, and if you want to try it, go ahead. Okay, try it without me first, or if you feel like you need support, then go ahead and keep watching. Okay, the first thing I'm going to do is I'm going to identify what it is I want to solve. I really want to find x, and so x, if I use x, I'm going to have to use 12.5 because that's on the opposite side, and now we have a choice. Do we want to use 6 or do we want to use 9? If I use 9, that's going to force me to use y. And that's a problem because now I have two variables in my equation. So I'm going to use 6 and 5. So my setup now looks like this. 6 over x, equals 5 over 12.5. Okay, so that's a perfectly good setup. Let's do some cross multiplying. 12.5 times 6, that gives me 75. And then I get 5x when I do 5 times x. And that gives me x equals 15. It's always a good idea to double check and make sure that number makes sense. Okay, so 6 was a little bit bigger than 5, so whatever we get here should have been a little bigger than 12.5. 15 is a little bigger than 12.5. Okay, so that gives me some comfort in feeling like maybe that's going to be okay. Okay, now we want to find y, so I'm going to come down here, identify y, and I've got 9, and we've made a note that this is 15. And so now we have to decide, we have y and 9, what numbers are we going to decide to make proportional to those? Okay, and so we have a couple options. We could do 15 and 12.5, or we could do 6 and 5. Now, both should work. However, one is much better mathematical practice than the other. Which one do you think that is? Okay, it's far, far better to choose 6 and 5, and there's actually two reasons. Number one, they're smaller numbers. They're easier to work with. We should like to work with smaller, easier numbers. There's no decimals. We're less likely to make a mistake. But there's one other reason why it's better to pick 6 and 5 than 15 and 12.5. We don't know for sure that 15 is correct. Now, we feel pretty good about it, and it sure seems like it's right. But there is a 1 in a million chance that we made a mistake and that that's not right. And if that number's wrong, and we use it in this calculation, then we can guarantee that the value we find for y will also be wrong. So I'm not going to use 15 right now. I'm going to use 6 and 5. 6, 5, and then we have 9 down here, and y. Oops, excuse me, I've made a mistake in my setup. Did you catch it? Okay, so 6, 5, 9, y. Okay, and now let's run through this. So I get 9 times 5 is 45, and I get 6y, and we're going to do 45 divided by 6, and that gives me 7.5. Again, we're always going to check and make sure our answer makes sense, make sure it's reasonable. Okay, 6 is bigger than 5. We would expect 9 to be a little bigger than whatever we have here, and 7.5 is that number that's a little smaller than 9. So that suggests that we're doing a pretty darn good job on this. Now that we've had a few examples, this would be an awesome one for you to try on your own. See if you can get it. If you can, you know you're making really, really good progress. If not, then maybe it's time to come in and get a little help and have some more discussions face-to-face to understand this a little better. Okay, so pause the video because I'm about to show you how to do it. I'm going to write down both my setups on one, so it's going to go pretty quick here. So I'm going to put x over 2, and you may have had those backward. I mean, you may have flipped them. That's okay. Okay, that's going to work, guys. If you had that flipped, it's not a problem at all. I'm just going from x down to 2. So x and 2, and then I get 1.7 and 1.7. Oops, not 1.2, 1.7. And when I cross multiply that out and solve, I get x equals 2. Okay, now to solve for y, I've got 3 in y, 2 and 1.7. And this one, I'm going to show all my steps. So 3 times 1.7, and I get 5.1 equals 2y. Let's divide out the 2. And I get 2.55. Okay, so this is a really good chance for you to check and see where you're at. Again, if you need more help, come on in. We'll get you a little extra help. Okay, now let's take a look at the triangle angle bisector theorem. Okay, and so I've abbreviated it here. It's not actually a tab. Notice those are capitalized. That's triangle angle bisector. Okay, and here's all it says. It says if you have a triangle and you've got an angle bisector in that triangle, then it's going to create proportional side lengths in those triangles. Okay, and so those side lengths would be like this, like A, B, C, D. That would allow you to set up a proportion. Notice we do have an angle bisector. The way I can tell that, remember that marking, and that marking means the two sides are the same, which means the bigger angle A has been cut in half. That allows me to set up a proportion like this. A over B, C over D, very similar to what we just learned. So today we're kind of learning little tricks when we can use proportions that maybe it wasn't obvious that we could. Okay, let's look at an example. Okay, and here it is. Go ahead and get it written down. Okay, and the setup is real simple. All we're going to do is we're going to set it up just as it looks. 24 over x, and then we could have 40 over 30. Okay. Now, some people in class the other day, they had said, but wait, Mr. Boyden, if we start with 24, isn't the corresponding part to 24 40? And they draw in the little arrow, 24 to 40, kind of like what we learned in 7-2 and 7-4. And they said, but wait, and Mr. Boyden, wouldn't we then have to go from x to 30? Okay, because they were relying on their previous understanding. Well, I want you to see what happens when we do that. I want you to see the similarities and differences between these two setups. So watch what happens. In the one on the right in the blue, we end up doing 30 times 24, which is 720. And then we do 40 times x, which is 40x. Okay, what about over here? We still have 30 times 24. So that means they're logically equivalent. And so we still get 720 equals 40x. So since we end up with the same next step, that tells us that both of these setups are accurate. So if you like to just look at it and say, hey, I'm going to set these up exactly there. Top left, bottom left, bottom left. Awesome. If you want to look for corresponding parts and do it the way that we've learned previously, that's also going to work. Okay, so two different ways to understand this. It does not matter to me which one you do because both of them are perfect. Okay, so we're going to do 720 divided by 40. And when we do that, we get 18. And we always want to check, make sure that makes sense. 40 is a little bigger than 30. 24 is a little bigger than 18. So that gives us some comfort that maybe this is right. Hope you all enjoyed the video. That's all for today. See you all next time.